Welcome to Energy Innovations, a regular video series that explores the latest innovations in technology, digital, regulations, products, services, finance, and business models that are impacting the energy sector. Energy Innovations interviews entrepreneurs, energy companies, capital markets, and regulators to understand how the energy industry is changing.
Welcome back to Energy Innovations, and today's conversation is going to be on a fast evolving but very important technological innovation called robotic industrial process automation. And the leader behind this drive to improve our industrial processes is Vicki Knott, who is the CEO and founder of a company called Crux OCM, which is pioneering this technology in industry. Vicki, welcome to Energy Innovations this morning.
Hi, thanks for having me.
Now, let's begin right away with what exactly is robotic industrial process automation, and how is it different from what people might think of as just regular process automation?
Yeah, so there's two versions of there's industrial process automation, so control systems. Then there's also RPA, so robotic process automation. So, and how it's different from the two is it's kind of a combo of the two. So when, like your traditional robotic process automation, you're automating things in your finance or your legal departments or your administrative departments, right? So how you copy paste files. So greatly simplifying your workflows, making it a lot easier to be able to do those routine tasks. So then when you look at process automation with respect to heavy industry, so you're looking at the automation of, the control systems for your pipeline, for example, or a gas plant. Those are currently controlled by what's called DCS, or distributed control systems, or SCADA systems, supervisory control and data acquisition. So that is very focused on the equipment and automating the equipment. So robotic industrial process automation marries the two in that it's focused on how a human interacts with that heavy industrial equipment. So automating human workflows, but as it's pertained to the equipment. And so what that means is that, you've got your control room operator who's operating these assets, and they're using paper procedures, checklists, and rules of thumb. There's automation inside of the SCADA system or inside of the DCS, but it's actually automating how they execute to operate the assets, as opposed to how the assets themselves are automated. So hopefully it's kind of a weird mixing of the things, but that's why we had to give it another name, is because nothing really made sense.
Yeah, robotic process automation is a long-standing technology. It literally came out of the gaming industry, 15 years ago, when gamers who would need, in the middle of a game, need to run around and, collect coins and purchase their armor and equip their persona for the venture ahead, develop these little robotic routines that would go and automate these tasks. And so the technology's been around for a long time, but for some reason it never got into this control environment. Do you have any idea why that's the case? Like, why would control room environments, which you would think would be highly automated anyway, why would they continue to have, after such a long period of time, such a low level of process automation?
I think it's just the general human, if a human's touching it, it feels safer, right? And I think we're only just getting to the point where it's becoming very obvious through data set after data set that when the computer completes the more routine tasks, it's significantly safer. I think that society's just starting to get to that point and understanding it. Then there's also the marrying of technologies, right? So to be able to execute the automation of, control room operator procedures, there needs to be, a platform that can handle process control, advanced process control technologies. You need to be able to handle, fundamental physics modeling, as well as machine learning for soft sensors. So it can be done again with all these different pieces, but marrying all the pieces together is how you can actually create the platform to achieve it. And it just hadn't been put together before.
Now, your background includes a stint as an actual control room operator. This is where you first saw this playing out, and it kind of came home to you that there had to be a better way?
Yeah, that's exactly where it came home. So I trained as a control room operator, and it was, there was so much pride in how difficult it was to start up a pipeline. But it's like, okay, well, we've got these super complex pieces of technology in our hands that are really well automated. And like why are we still doing this way, right? Like the technology exists to automate these activities. Why aren't we doing it? Like I love to always throw it back to like, pilots in planes have autopilot software, right? Like we're not going to fly from Calgary to Houston in a plane that doesn't have autopilot software. We're not going to do it. So that doesn't feel safe to us. Yet our critical infrastructure that runs our economy globally doesn't actually have this. We've got all the safety guardrails and all that great stuff. That's excellent. But what about just operating it, on that optimal flight path and automating that activity?
Yeah, it's a great point. Why do we accept this logic in one part of an industrial life where hundreds of lives are at stake? There's thousands of flights every day, millions of kilometers flown, and yet for the control room, which is say supervising chemical injection into our water system, chlorine, for instance, we still have a person whose job is to move the mouse to make sure that those settings are all correct. It kind of boggles the mind, actually, when you start to think about it in those terms.
Yep.
Now,
it sure does.
It does. Yeah, exactly. Now, you touched a little bit on why this is particularly complex problem to solve. I wonder if you could unpack that a little bit. It sounds like we've got things at play here: diversity of equipment, complicated procedures, multi-ages of equipment out there. Is these the sort of things that makes this a particularly thorny area to work on?
Yeah, absolutely. Because there's a lot of capability in the existing systems to go through and create some of this automation, but not all, right? And I think the point that's missed too is somebody, if you go back to the RPA example, somebody could have created a one-off script, right, to automate copy pasting these files. But then, that would have been used, that one tool would have been used by like one or two employees across the company, wouldn't have been scalable to the whole company or across an industry. And then that's where RPA came in. And that's where I think, the same idea is required in our IPA. But again, it's more complex because, you can do a one-off consulting job to automate, a pipeline swing, say, or something like that. But what you're completely missing is, can you then put that on all of your other pipelines effectively? Can you then actually maintain that? And then can that be scaled to include other functionality as a platform type offering? So that, that's more of, I guess, the business model considerations around why it's a bit more complex, right? Like anybody can solve any problem one off, but is that actually scalable and sustainable for a business? And then on top of that, the actual knowledge of advanced control technology and being able to marry that with how a human executes, as opposed to how equipment is supposed to execute. That's a complete mind shift that I've actually never seen in the industry. So adapting the existing control technology to simplify how a human executes their set point changes, as opposed to putting that technology on a distillation column and having it manipulate set points that way. It's a different angle.
And so I imagine like some of the voices in industry that would say, look, this is not something you can safely automate or carefully automate, would say that it requires a human with the intellectual processing we all innately have to be able to figure out the set points and the like. Is that accurate, or is that a mythical position that we hold on to for some reason?
It's a mythical position we hold on to defy change, because at all costs we must not change, right? So it's it's whatever people need to tell themselves works. But yeah, it's the technology exists. Like people aren't good at doing repetitive tasks, right? Like, and every control room operator is going to do things differently. There's study after study showing that someone's going to behave differently at 2:00 in the afternoon than they do at 2:00 in the morning, right? So like, the technology exists and it's safe, and why wouldn't we?
Yeah, why wouldn't we? Yeah, I think it's instructive to me. There's a little story I like to tell. This bot technology is so efficient. It's so good. It's so reliable. It's so inexpensive. It's actually banned on products like platforms like LinkedIn because it's so good. Elon Musk's Twitter deal right now is all hung up because he's concerned that the accounts on the platform are bots. And most of us interact with the platform. We wouldn't know if we're interacting with a human or not. That's how good these things can be. And so it just begs the question, why would we not bring these into our industrial landscapes to take full advantage of them?
Yeah, and back to the safety part too. It's, you're not going to get in a plane, like we talked about earlier. You're not getting a plane without autopilot software, but you're not getting in a plane without a pilot. You still need the human eyes. Like if things are going sideways, you need someone who can kick out the software and land the plane safely. And these technologies are not saying at all that that's not required or that's not important. It's looking at it from the angle of do you want your pilot to be stressed out and exhausted and then they've got to land the plane, or do you want your pilot to be fresh because the software's been doing its thing for 10 hours and now things have gone sideways and your control room operator's ready. He's used the bathroom, he's had lunch, right? Yep. That's what you want.
Yeah, I remember years ago I used to live in Hong Kong, and for fun I would take visitors to the Kai Tak Airport, as it was called at the time, and we would stand under the runway and watch aircraft fly in. And it's all international flights because it's Hong Kong after all. And the aircraft, they would come in, they would bank. There was a 90-degree bank because when it was flying in from the ocean, and the aircraft would literally go sideways to avoid a mountain. And in that 90 seconds, it would come in straight, do the bank, then straighten out, and then land. And it was terrifying to watch because you knew all those pilots had just finished a 12-hour shift, and now they're asked to do the most complicated maneuver. I think it's really interesting that if you think about it in those terms, why would you not pull this into your operating environment? But surely some would say all this SCADA equipment that we have, the DCSs out there, they're already automated. Why is there incremental automation required here? Maybe you can unpack a little bit why incremental automation actually brings value here.
Yeah, I love that. Yeah, I think there's, it's just folks who are familiar with SCADA, they've seen its capabilities. They've probably seen it come from, where there wasn't SCADA to now there is SCADA. So they're like, oh, but we already do all these things. But during that time, the operations have gotten more complex. So if you think of a pipeline system, they've the M&A activity, we've added a few more lines. And so now you've got Frankenpipe, and now your control room operator's trying to figure out how to navigate that. So as we get more complex in the operations, then so comes the need for that incremental automation. So then to your question of what's the value of it, every time that your control room operator is maintaining your max rates on your asset, whether that's again a gas plant or refinery, and refineries are very familiar with this, why this is important. But you think of the same thing from an oil pipeline. Every time you're maintaining your max rates, that's straight up volumetric throughput for your customers, so your shippers, and prices at the pumps, right? So super important to be maintaining max rates and having a reliable way to continually do that, being able to start up faster, shut down faster. All of that is efficiency. Efficiency is green, and efficiency is straight up revenue on these assets, right?
A related challenge, though, and I would say specifically in the Canadian context, is that it's now a struggle to add fresh infrastructure. How does this kind of robotic automation capability for industrial use, how does it actually free up capacity or help you capture latent capacity you can't otherwise get?
Yeah, so in the pipeline sector specifically, that's one of the reasons why we wanted to do this. We realized that control room operators were overworked and that it was a rough job. We wanted to help them out. And then we realized that, hey, there's incremental capacity to be had here. So many large transmission oil pipelines are somewhere between 85 to 92, 93% utilized, right? Folks will say, well, we need 100% of our contracts. Sure you do, but that's great. But your contracted amount is actually only 92% of your pipeline capacity. So being able to capture that incremental volume is extremely important, especially in a landscape where you cannot build infrastructure, right? That's the only option you have. And so I think we really need to be jumping on it.
Now, this incremental capacity, as you point out, where does it come from? I'm trying to visualize now. You've automated some procedure. Where's the capacity release that you're referencing here? It's not like you've built another pipe. So where's the capacity?
Yeah, so I'll break it down a little bit more. So really, if you think of your pipeline and you're at say 90% utilization, so that means 10% of the time this asset's not moving volume. Now maybe that's because of scheduled outages, maybe that's unplanned outages. There's also this thing in pipeline that's called the natural one company that I've worked with is called the natural reduction factor. So it's like, it's the differences between your control room operators and how they operate. And, some are going to operate a bit more aggressively and get a bit more throughput in their shift, and some are not. Some are going to be trainees and new, and they're going to make mistakes, and that's okay. And some of them, sometimes it's 3:00 in the morning and you forget to do something, right? Like that happens too. So all of those types of activities, then when automated, create that consistency, and that consistency then gets you closer to that, that max throughput line over time. So you're not kind of wiggling along what you could be your max throughput. You're kind of maintaining at it. And then what that does over a time frame, so say over the course of a month, instead of your utilization of your asset being at 90%, it's at 91%. And if you're at 91%, that's capacity that you can then go and sell back to your shippers, because you can reliably move it. And that's where the efficiencies are.
That's where the gain is, yeah. And that 1% doesn't feel like a lot, but when you look at the size of the pipe, the amount of barrels you're moving, or the quantity of gas you're pushing, or water for a water treatment facility, that 1% over time adds up to a ginormous amount. Like these 1 and 2% increases expand economic throughput dramatically.
Exactly. And it's and also thinking about it from like an ROI perspective, right? Like this is software. This is software that you can get into the systems in a matter of months, not pipeline projects that take 10 years, right? Yeah. And the costs are significantly less, and you can do it with just a vendor and the people you already have on staff, right? So if you actually look at the net present value of being able to use technologies like this versus, the good fight and the good fight to get another pipeline in, like, keep fighting the good fight, but like, why not use some of this stuff too?
Yeah, exactly right. How many holes do you have to drill? And that's just a veiled reference to a management of change process. What is the management of change process that you then have to deal with, given that you're deploying software like this, which is automating procedures that effectively already exist?
Yes. So that's, we are very familiar with the CER and PHMSA regulators, in the US and in Canada. Huge mandates, especially with PHMSA, around reducing control room operator fatigue. So things that reduce control room operator fatigue are very much, smiled upon. And then, of course, both of those governing bodies make sure that all of our infrastructure operators work with control room management of change procedures. So making sure that, everybody's onboarded correctly, folks have the training that they need to be successful, folks have access to the procedures, and that, if something's changing, they're properly onboarded for that. So with respect to bringing in a technology like this, it's got to be compliant with all of the control room management of change, and that's a two-way street, right? Like that's not just the vendor. The folks in the control rooms in these companies have to have that management of change set up and ready to take in a new technology. Thankfully, for a new technology like RIPA, or robotic industrial process automation, the goal is to simplify the procedures, not make them more complex. Therefore, what we've seen with current clients with the management of change is it's actually not very onerous, because you're making it simpler, not harder.
Yeah, I imagine the intellectual horsepower it takes an operator to keep on top of things. You're actually lowering the demand on their cycles. And that has to ease the stress level, has to ease the fatigue factor, allows the operators to deploy that horsepower that they've got to problems more important to the organization than moving the mouse from here to here to make sure that this switch setting gets reset. Absolutely. And like as reported by PHMSA, like the leading cause of safety and environmental accidents in the pipeline sector are control room operator fatigue related. Like that's what it is. So like that's, there's lots of work done around alarm rationalization, lots of work done around like the colors of people's screens, the lighting in control rooms. But like let's attack like the actual root cause. Like these guys have too much to do. So how do we automate and give them less to do? Yeah, precisely right. Where does this apply now in industry? What kinds of industrial sectors have approached you to say this is something we could use in our environment? Yeah, so we've been approached. Oil pipelines is the first place that we're seeing rapid adoption. We've been approached by gas plants, refineries, wind farms, coal plants. Recently just got a question about electrical grids, which I'm really interested to dig into too. So think of any place with a heavy industrial control room. That's where I believe this is applicable. And there's a lot of control rooms out there. A typical oil sands environment, for instance, will have multiple facilities that need to be managed. And so there's a potential, a significant scope. Now let's turn a little bit to the environmental angle. You mentioned just in passing that there's an environmental dimension to this. Can you just unpack the ESG factors that you're trying to influence here?
Yeah, so I think that the ESG factors that we're trying to influence are, maybe considered a little more indirect, right? And I can't remember what the tiers are, but there's things that describe that.
Yep.
But if you look at the energy transition as a whole, right, like the first step is making existing infrastructure efficient, and you have to do that because if all the investment is now going into solar and wind, and we've got aging infrastructure, and we're not building new pipelines or new plants and stuff, well, then we really need to make those significantly more efficient. So, efficiency is green. If you're able to increase the utilization of your asset, then you're very likely also reducing, the energy per barrel required to actually move product, right? And that is green. There is an ESG impact there, right? And it's a short-term win, right? Which I think, again, people miss. It's like, they're looking at the big multi-year, hundreds of millions of dollars project, and it's like, well, you can get a win now, and you can report that to your investors through software, right?
Very powerful. There's another dimension you touched on, but we haven't really explored, is the whole, again, with the operators, the fact that this technology allows your junior operator to behave at the same level as the most senior and experienced operator. I think it creates or solves for a talent challenge that this industry has, which is bringing on board talent. Have you heard? And this is a social issue because we need to find young people to take on the roles of machine operators. Have you found clients reporting either challenges with hiring and retaining staff? And does this kind of capability help ease some of these talent pressures?
Yeah, totally helps ease the talent pressures. So like I give you some anecdotes.
Anecdotes are good.
Sorry?
Anecdotes are good.
Anecdotes are good. So I had a lead control room operator look at me and say, back 5 years ago, I'd get 300 plus job applications for a control room operator role. He's like, last one I posted, I got 8, right? So if that is not a wake up call to execs in oil and gas, I don't know what is. And then I also had another anecdote. I had a senior control room operator tell me, he's like, 5 years ago, you came in here peddling this. He's like, I would have told you to get it. I would have kicked you out and kicked you on the way out the door, right?
Yeah.
He's like, but now he's like, these young folks aren't interested in these jobs. They treat it like a video game. They don't have the field experience to understand how the assets actually work. He's like, so we need better automation to help these folks be able to actually do this job and be able to execute on it. And so that's where the automation is extremely important, right? Like, you've got an aging workforce. They're all retiring. They're taking all this knowledge with them. And you've got 8 applicants to backfill. And what is the probability that, we all know millennials and Gen Z, like we aren't lifers at companies anymore. So the probability of an operating oil and gas company being able to actually retain that knowledge as the workforce changes is 0, right? Because someone's going to be in that role for a few years and they're going to move on. That's what they do.
Yeah, the pressure to figure out how to take the grunt element out of this is now extremely high. There is a slight risk, though, that I could also see. Maybe you can comment on this. If we bring these industrial process automation tools into the machine room, do we rob the junior folks of an opportunity to learn how this equipment works? And therefore, are we depriving ourselves down the road of a more experienced workforce? Or is that yet another one of those myths out there that we need to dispense with?
I think it's still a myth that we need to dispense with. Like, I think, again, the aviation industry is a fantastic model for this, right? Like, you still trust the new young pilots because they've gone through flight training, they've gone through simulator training. If anything's going wrong, they know exactly how to take care of it, and they're fresh and ready to do it. So that's the same mindset that has to be taken over here as well. That's why control room management of change regulation exists, right? Is to make sure that folks still have that training and they still are able to be able to get hands-on if they need to. And as prudent oil and gas operators, they still have to invest in making sure that their people have those skills. It's just, how do you make it significantly easier to get them up to speed, right? How do you make it significantly easier if you're having staff turnover? How do you potentially have someone, because you can't get enough people, how can you potentially have someone handle a little bit more, but without them having to have mental breakdowns or quit on you, right?
Right. Or create an incremental risk to your operation, because you run the risk that they're going to do something inappropriate just out of lack of experience. That's
Totally.
cause some challenges there. Let's just wrap up with, if you could, help summarize what you see as the economic angle here. If you're meeting someone new and they're just learning about this, how do you express to them, here's the size of the economic prize, and how do you break that down for them?
Yeah, so the size of the economic prize is really in that, like, first of all, typically in the initial volumetric throughput, right? So specifically if your pipeline is at max capacity, but even if it's not at max capacity, how can you automate automating the operation of the asset based on minimizing power costs? So there's a cost savings on that side, but the incremental capacity on the assets that are full is what has our current clients really quite excited. We've got current clients looking at over 100 million in additional revenue because of the way that their infrastructure is set up, the way that they're tied into the markets. So they're able to move some spot volume, or they're able to move some incremental capacity on a contract that's a really good deal for them. So that's where the value dollars with respect to revenue can come in. But then there's also if you look at the equipment reliability, right? Like if you're operating your equipment in a nicer, smoother way, the same way every time, you're going to get a little bit more life out of that equipment, right? Rather than having the junior person operating Rammy.
Yep.
and then you're pressure cycling on specifically your pipeline assets, being able to minimize that through automation. All of that has positive cost saving, less tangible than the straight revenue, but really positive cost saving opportunities.
Yeah. It's a very interesting economic story. Let's just wrap up with one final question. Where do you see this technology headed down the road? And let me pose a provocative observation for you. In the same way that we have an aircraft with an autopilot, and the pilot only occasionally touches the controls when it's necessary to maintain and minimize risk, we end up with effectively automated aircraft. Where does this process automation go in the industrial sense? Is there a day out there where we will have fully automated, lights out industrial process equipment, no control rooms, where the technology is actually able to operate in this sort of lights out, pilotless model?
I think we're a long way from it, but I think that's exactly where it goes. Like, I think the concept of industrial autonomy has been very much only looked at from the equipment and the machines, and not looked at from the human side of the people that actually interact with it. But that's what needs to be automated, is how the humans interact with it. Once you get that automated, then you can start looking at true industrial autonomy. Maybe it's not full lights out, but maybe it's, your field staff who is going around and doing the routine maintenance on valves and whatnot. They're carrying a tablet with them. And with that tablet, they can actually also operate the asset. Right. So maybe it becomes that more like a more interesting hybrid workforce. These assets will probably always still need people around them, but it might look very different than what it does now. But if you zoom back 30 years, it looks very different now than it did 30 years ago, right? Central control rooms versus people driving around in trucks to each pump station. So it's already done that. So it's just, give us another 20, 30 years, we'll be at the next evolution.
And I suspect as we add more sensors, more data inputs, more variety, more analytics, more regulation, the role of that operator to be able to cope just gets harder and harder, which creates even more demand for how much of this can we actually sustainably automate. So
totally.
the future is looking very bright. We should put sunglasses on, I think, if we're talk about this. Vicki, it's been...
Mine are not transitions. I got to get some better ones.
Exactly. Vicki, it's been a pleasure to bring you on to Energy Innovations today to talk about the Crux OCM and its innovations. If people want to learn more about what you're up to, where would they seek you out?
So the website, cruxocm.com. We've got a very active LinkedIn. My personal LinkedIn, we're posting lots of great stuff. We've got a YouTube channel where you can totally learn more. Reach out to me directly, Vicki at cruxocm.com. Would love to chat and see how we can help.
Vicki, it's been brilliant. Thanks very much for coming on the show today.
Thanks, Jeff.
This has been another episode of Energy Innovations. And if you like what you've heard, please press the like button or share this with your network so that others can take in this content. And I'll return shortly with another episode. Bye for now.
Thanks for joining our latest interview on Energy Innovations from EnergyNow Media. Don't forget to hit that like button, subscribe, and share this video. You can contact us at info@energynow.com to book your appearance or to become a sponsor.